Hello and welcome to this new video. In the previous video, we integrated the voice engine service into the game. In this video, we will integrate a player stats management system into the game. It is worth noting that the Steam plugin does not implement the Unreal Engine stats interface, as Steam handles player stats differently. For this, the Easy OSS plugin provides a solution to manage player progression for Steam. This is done through the implementation of the web APIs provided by Steam regarding the integration of player progression into the game. When we talk about a web API, it means that we are working with HTTP requests to implement these APIs. Easy OSS implements these Steam APIs and offers an easy blueprint solution for integrating the services into your game. It is recommended to read the Steam documentation for each web API to better understand the functionalities. Each functionality of a web API requires a Steam Publisher Web API key, which can be obtained from your Steamworks application. Here's an important note: the Publisher Web API key allows a user to manage everything in your Steam application, so you should never share this web API key in your game client. In a real game, you should implement the web API functionalities on a secure server, such as a dedicated server, since the game server is part of your game and will not be installed on the clients. In this tutorial, to keep things simple, I am implementing all the features of the Steam web APIs on the game client since my lobby level runs on the game client. In a real game, you should host your lobby on a dedicated server, for example, to secure access to the web API features. To start, we will go to the Player Stats widget to adapt it for Steam. Here, we need to remove the implementation since the Steam plugin does not implement the Unreal Engine stats interface. To work with Steam stats, you can find all the features related to Steam stats and achievements under Easy OSS Stats Steam. It is worth noting that Steam uses the same web API to handle both stats and achievements, so they are all under Steam stats. Unlike EOS, for Steam, the game client does not need a solution that provides the stats names in order to query them. The Get Steam Game Stats and Achievements task is used to return the list of stats and achievements for the game. This task, like other tasks from the Steam Web API, takes the Publisher Web API key and the Steam App ID as parameters. The language parameter is optional and is used to return the results in the specified language. If not specified, the default is English. To understand the returned results, each array is an array of structures. The game stat structure contains all the information regarding a Steam game stat, and the same applies to the game achievement structure. A game stat is represented by a name, a default value, and a display name. The Get Steam User Stats task is used to return a player's Steam stats, allowing you to retrieve the player's score for each game stat. The stats are a map of string to string, where the key is the stat name and the value is the player's score for that stat. We can observe that there are two different things. Obtaining game stats returns the information of a game stat, while obtaining user stats returns the score of a specific player. So, in this widget, we will display a table containing the game stats and a table containing the user stats. The Get Global Stats task returns the list of game stats defined as aggregated. On Steam, when creating a stat, it can be aggregated. In this case, this task will be used to obtain it. Note that the Get Game Stats and Achievements task returns all stats, regardless of their type, aggregated or not. An aggregated stat is used for the concept of total. For example, if we want to know the total number of jumps by all players, we define a jump stat as aggregated, and Steam will automatically calculate the total number of jumps made. I want to add a third table in this widget representing the global stats. The global stat structure contains the stat name and the calculated total value. We will base ourselves on these three structures to create the three tables. Delete the existing implementation. Since the Publisher API key and the Steam App ID will be required for all the Web API tasks, I want to get them from the game instance. Go to the game instance and then to its interface to add these functions. Add a function that returns the Steam Publisher Web API key. Add the function that returns the Steam App ID. Implement these two functions. Here you must put your own app ID. Here you must put your Publisher Web API key. If you don't have one, it can be generated in your Steamworks application. Go to Users and Permissions, then to Manage Groups. If you don't have a group, you need to create one. Click on the group. Here you should have an option that allows you to generate a Publisher Web API key. For me, it's already generated, so I just need to copy it. Add the onConstruct event in the widget to retrieve these two pieces of information from the game instance. Promote the outputs to variables. I want to add a custom event that is used to refresh the widget's UI to update the table information. Add a timer that continuously refreshes the UI. In the designer, we will add the three tables. I will modify the existing table to make it suitable for the Steam game stats. Duplicate the table twice. The table on the left will represent the user stats, and the one on the right will represent the game stats. Add the global stats table. Rename the player name column to stat name. Rename the stat name column to display name. Rename the score column to default value. The global stats table has two columns, the stat name and the total. The user stats table is already good, we won't touch it. The first thing to do on each refresh is to clear the 3 scroll boxes. We need to get the user stats for each target user, so we need to loop through the list. Add a custom event that is used to get the list of stats for a user. Call the Get Steam User Stats task and then connect the inputs. Connect the Steam user ID to the event. Display an error message if the task fails. Here we need to add the user stat item widget to the scroll box. We will fix this widget later since it is not fixed yet. The stat score and name can be obtained from the returned map. We add each created item to the user's scroll box. Call this event for each target user. Once the loop is finished, we need to proceed with the game and global stats. Add a custom event that is used to get the game stats. Call the Get Steam Stats and Achievements task and then connect the inputs. Display an error message if the task fails. Loop through the array of stats returned in order to add the item widgets to the game scroll box. We haven't created the item widget representing a game stat yet, so we will duplicate the user stat item widget and adapt it for a game stat. Duplicate the player stat widget. Rename the input variables to match a game stat. Add the widget by connecting the inputs. Once the user stats are obtained, call the custom event for the game stats. Add a custom event to get the global stats. Call the Get Steam Global Stats task and connect the inputs. We need a list of stat names to query. What I want to do is to collect the stat names from game stats. Add a variable of type array of strings, then add the stat names to it. Connect the array to the input of the task. The start and end inputs are optional. You can use them to get the daily total. Display an error message if the task fails. Loop through the list of global stats to add them to the global scroll box. As we did for the game stats, we need to duplicate an item widget to create the global stat item widget. Duplicate the game stat item widget. Remove one column since the global table has only 2 columns. Add the widget by connecting the inputs. Add the widgets to the global scroll box. Call the event after the game stats event. We will now go into the master player controller to change the implementation of update stats. As a reminder, the client calls this implementation to update its stats. The current implementation uses the Unreal Engine Stats interface, which is not implemented by the Steam plugin. We will therefore replace it with a call to the Steam Web API dedicated to updating stats. The Set Steam User Stats and Achievements task is used to update the values of user stats and achievements. The input map is a key-value pair, where the key is the name of the stat or achievement to be updated, and the value is the value to be associated with that stat or achievement. You can therefore use the same process to update a user's achievement. You just need to use the achievement name instead of the stat name. Then, add this map to the input of the custom event. Connect the other inputs. Here, we set the stat or achievement for the local player, so we connect its user ID. Modify the interface function to correct its input. Now go to your character blueprint to fix the implementation of the jump stat update. It is important to note that on Steam, the value given to the stat replaces its current value, whereas on EOS, the given value is the amount of update that EOS will use to calculate the final value of the stat based on the stat's aggregation type. Therefore, we need to get the current value of the stat in the event begin play, and then we need to calculate the new value to update on each jump. Create a custom event that runs on the client and is used to get the current value of the jump stat on begin play. Obtain the Web API key and the app ID from the game instance. Call the Get Steam User Stats task to retrieve the list of stats for the local player. Note that this task only returns the stats that have already been updated for this user. Promote the stats to variable. Call this custom event in the event begin play. Now, we need to calculate the new value of the jump stat based on the current value. Find the current value from the stats variable. The name of the stat to provide here must be the same as the one we will create in the Steamworks application. The new value is the current value plus 1. Care must be taken for the first stat update. In this case, the stat is not returned by the Web API, so for the first time, we need to set the value to 1. Once the stat is updated, we need to update the current value so that it becomes the last updated value. When retrieving the global stats, we need to check that the list of stat names is not empty, otherwise the task will fail. We will now create the jump stat in the Steam application. This is done in the Stats and Achievements section. Here you can find the documentation for the stats interface. The stat must have a type, and the types are int, float, and average. For our case of the jump stat, the type is int. You will also find the documentation for the other properties of a Steam stat. The API name must match the name of the stat that we use in the character blueprint. Since we set the stat via the Web API, using a Web API publisher key, Steam considers it as the server or the official server setting the stat. Therefore, it should never be defined as set by client, as this will not work with the Web API. Set by client should be selected for applications that implement the Steamworks SDK, not the Web API with a publisher key. Currently, Easy OSS does not implement it, but we aim to integrate a Steam solution via the Steamworks SDK. Check the increment-only option, which means that the new value of the stat must be greater than the current value. I set a max change of 1, which means it is an increment of 1. The min and max values are optional, but I define them anyway to create a range. The same goes for the default value. If it is not defined, Steam sets it to 0. If you want the stat to be treated as a global stat, you must check Aggregated. I provide a display name. Click on Save, then publish your changes. Launch the game to test the implementation. On the right, you can see the game stats. Currently, we only have one stat, which is the jump stat. If you don't see anything, wait a few minutes, as Steam may take some time to update the backend with the Web API. On the left, we should see nothing. In my case, I can see the user stat for player 1 because I've already performed several tests, and the backend has data for this user. However, we see nothing for player 2 because the backend has no data for this player. The same goes for the global stats. We shouldn't see anything for now. For me, I see a total of 11 because I have already performed several tests, and Steam has already calculated a total of 11 jumps. This may not be the case for you. Start a match and then perform several jumps. Return to the lobby to check the stat. You need to wait for the update on Steam's side. The stat has been updated, but Steam does not immediately return the new value via the Web API. After a few minutes of waiting, I can see the correct values. We can see that player 1 now has 4 jumps, and the global jump stat should have a total of 15. We just need to wait for the update on Steam's side. In the meantime, I'll launch player 2. Player 2 can see player 1's stat, but the total is still 11.
So, we need to wait.
Start a match on player 2's side and then perform a few jumps. Return to the lobby and check the values. After a few minutes of waiting, I can see the correct result. Player 2 has 2 jumps, and the global stat is correctly 17, which is 11 plus 4 plus 2. This delay with Steam should not occur in a live environment. On player 1's side, we also have the correct result. And that's it, everything works as it should. That's all for this video, see you in the next one.